Dzień dobry Państwu. Witam serdecznie w imieniu Connect Distribution. Ja nazywam się Sławomir Karpiński. Będę miał przyjemność jedynie w tle moderować całym spotkaniem. Natomiast głównym prezenterem dzisiaj będzie pan Stefan Merkel, Senior Solution Architect z firmy DataCore. I to będzie główna, właściwie jedyna część prezentacji. Dosłownie jeszcze minutkę bym zajął Państwu tytułem wstępu. Dla tych z Państwa, którzy byli na naszym spotkaniu partnerskim 16 września, pamiętacie, że października, nie, jednak września, pamiętacie, że była tam krótka prezentacja na temat DataCore'a, natomiast dzisiaj ten czas chcemy poświęcić na już pokaz głównego produktu, który w tej chwili jest takim przewodnim rozwiązaniem, które promowane jest przez DataCore'a, a mianowicie rozwiązaniu Swarm. Jeśli chodzi o DataCore'a, dla tych z Państwa, którzy jeszcze wcześniej kojarzą tą markę, bądź są też nowymi użytkownikami, przypomnę, że DataCore wyrasta z takiego pnia rozwiązań Software Defined Storage albo Storage Virtualization i to są takie najbardziej już ustalone kierunki rozwijane od ponad 20 lat. Tu mamy ogromną rzeszę użytkowników, grupę odbiorców. Natomiast niedawno, mniej więcej przed 3 laty, wraz z nowym zarządem, DataCore zaczął się rozwijać też w innych kierunkach, czyli poprzez akwizycję przejął dwie firmy, które miały wtedy ciekawe rozwiązania, których nie było w DataCore do tamtego czasu, a mianowicie vFilo. To jest rozwiązanie, które umożliwia zarządzanie dużymi zasobami plikowymi, czy to macierzowymi, czy w postaci po prostu serwerów plików. A ostatnio w zeszłym roku przejęta została kolejna firma, specjalista od właśnie rozwiązań obiektowych. I dzisiejsze spotkanie właśnie tej firmie, a właściwie rozwiązaniu tamtej firmy poświęcimy. Chciałem jedynie zwrócić uwagę, że jest to dość nowy kierunek jak na 20-letnią historię DataCore'a, natomiast kierunek bardzo dynamicznie się rozwijający i dlatego chcieliśmy wyłącznie na tym rozwiązaniu dzisiaj się skupić, czyli będziemy mówili o rozwiązaniach właśnie dla zasobów obiektowych. To tyle wstępu z mojej strony. Teraz przekazuję głos naszemu prezenterowi gościnnie. Będzie to pan Stefan Merkel, Senior Solution Architect z firmy DataCore. Stefan, the audience is yours, so you can start your presentation.
Okay, thank you. Hello, yes, my name is Stefan Merkel, Senior Solution Architect from DataCore. I think Slava also did an introduction. Today we will have a look on our new product, Swarm, which addresses the object storage space. And I will show you how the design will look like. And we will also take a look in our lab and we'll see how the UI looks, how the design looks like, and so on. So that's the design of our lab installation. In the end, the storage cluster where the objects are stored is the bottom box. These are the storage nodes. This can be physical nodes. Usually it is physical nodes, but it could also be VMs for smaller environments. In our lab, we also have the storage nodes deployed as VMs. And for that storage nodes, we have a separate storage LAN or VLAN that should be isolated to all other networks because in this network we have storage communication and also the storage nodes boot over network. So there is a platform server in the middle box of the screen. And this platform server is the management server, and that also provides the boot image, the network boot image for all the storage nodes. Then we have another network where you can see here the user service VLAN or LAN, and that is the network where the users are connected. They connect to the so-called content gateways, and there they can access the objects via S3 or HTTP. And also there is a content portal available and a storage UI which runs on these content gateways, and these are in the end these websites where the users can look inside the S3 buckets, show the content, search, and so on. And also the storage UI, which is more for the administrators to manage the whole environment. There is one component left, which I didn't talk about. That's the Elasticsearch Nodes. And Elasticsearch is, it provides the list of all the objects we have. And with that list, we can list all the objects, or we can search for the objects. And that's the task of Elasticsearch. All these components that we see here can be scaled out. The platform server is the only one that doesn't need to be scaled out. There is a maximum of 2 for high availability, but all the other components, content gateways, Elasticsearch nodes, and Swarm storage nodes can be scaled out as the environment grows. Any questions so far?
Nie, to wiesz co, ja słucham jakiegoś gościa akurat, bo jakiś produkt mam robić, ale
One question from my side, just to clarify the situation. It looks like quite complicated architecture,
Dobra.
but could you please let us know what is the minimum configuration? How we can think about the minimum configuration, I mean in terms of node, of servers. What would be the starting point just for smaller customer?
For the smallest environment that you can start with is 3 storage nodes, 3 Elasticsearch VMs, 1 platform server, and 2 content gateways. That's for redundancy. So if you don't need redundancy, you could use 1 content gateway, 1 Elasticsearch, and the 3 storage nodes.
And which components can be virtual and which have to be physical nodes?
In the end, everything can be virtual. If you start really small, then it's then it would be much cost to provide physical storage nodes. So with smaller environments, the storage nodes could also be physical. VMs.
Okay, thank you.
Any other questions so far? Seems not, then we will go for the environment. What I have here is our vCenter, where we see all the VMs we have. So we have, that's the group of our virtual machines we have. We have 2 content gateways in this case. We have 5 storage nodes, and we have 3 Elasticsearch nodes. That's search, Swarm search 1 to 3. And we have the Swarm service node, which is the platform server. There is one additional machine here, that's the telemetry that we will see that provides Grafana dashboard and Prometheus, and that's for monitoring of everything. But as I said, as you can see here, everything is installed as VMs, and that could also be the case in a productive environment if it's a small one. Then when we start here, that's the so-called storage UI. On the storage UI, we see what is our cluster. We see all the informations for that cluster. Here we see a health report. There is some, yeah, that's every area here in that circle means something. That's a cluster, that's subclusters, and here we have the different nodes. And then outside there are the disks which belong to that nodes. So that's a graphical view. We also see what's the disk usage, what's available. And there are some informations about Elasticsearch. And we can see some informations about network traffic on that starting point. Then we can go to the cluster here. We see what the hardware looks like. So that's our storage nodes. It recognizes these are virtual machines on VMware. That's shown here. We see the status of each one. Also informations about the disks, uptime version, and so on. We can click on one, and then we see additional informations. We get the logs consolidated for all of these nodes, driver messages, hardware info, and so on. Subclusters would be if we divide a big cluster into smaller pieces. The feed is the connection to our Elasticsearch. You can see here that's our primary search feed. And then we have some reports about system health, again, historical information, Elasticsearch information, and also information about that search feed, which represents the connection to Elasticsearch. Down here, we can do the settings for the cluster. So we can configure licensing, we can configure several details of the cluster. So that's the management UI of the whole cluster system. Any questions regarding that storage UI? No. Then I will switch over to the content UI. The content UI is the UI that a user can connect to the Swarm cluster. And on that Swarm cluster, we can have different tenants. So it's a multi-tenant system. So we have a system tenant by default, and then we have several tenants here that could in reality, that could be different customers, different users, and so on. So I'm working here with the Swarm demo, and there is a own domain represented for that tenant, which means if we use that domain, we will work inside that tenant. And here I configured a bucket called bucket 1. Here we can see informations, what's the capacity, the bandwidth, and so on. And we also see the content of that bucket. If you take a look here, there is one JPEG, there is one ISO, and there is one video file. So we can click here on that video, and we see we have sorry, that's the JPEG. We see what's inside the JPEG. We see all the metadata that belongs to that object, and we can edit that metadata, expand that metadata, and also search for metadata. Another interesting thing which makes Swarm very interesting for video customers or video streaming. If we take a look on that video, we can see we have the video player embedded here. So we can play that video directly from that content UI, and we see directly what's inside that video here. What we also can do is we can use that video, we can share it, which means we create a link, and we can use that link for external websites, which can then stream the video directly from the Swarm cluster. And yeah, that's the reason why we have many customers in the video and streaming area. And then we can also upload files here. So we can select local files and upload them into the bucket. So now we see a new object here. Here it is. So we uploaded that object into that bucket. If we connect to the cluster via S3 protocol, I prepared something here. I have a S3 browser, which is a tool that connects to S3 bucket, and you can work with that objects here. So that was the content of that bucket before I was uploading that file. So when I refresh that, we should see that new file uploaded here. So here it is. I can download the files I have here, and I can also upload new files. So that's the other way where I can upload a file. Here it is. And for double checking, we can just refresh that here, and we should see also yeah, here it is. Okay.
Question. You have mentioned that Swarm is work like in multi-tenant way. So it's clear for me that we can manage different tenants, but if each tenant is a separate customer, can the customer log into the user interface and just see their data without touching any other customer's data? Is it work like
Yes.
this?
Yes,
Okay.
sure. That's completely separated, and you can also use for different tenants different authentication sources. This means you could use Active Directory as authentication source, and then the user could log into that content UI with his Active Directory account, and then you make sure that only users from that particular customer can log into the corresponding tenant on that host, and it only the data is only visible inside that tenant. All other tenants are isolated from that.
Okay, thank you. And the next question regarding protocol S3. It seems in your example that Swarm is like S3 target. You can upload data to S3 through using S3 protocol. What other protocols can be used to connect to Swarm?
Yeah, we can have a protocol called SCSP. That's a development from Caringo. The company that developed that product, and they have also their own protocol, and that's another way compared to S3 to read and write objects over HTTP protocol in the end. We can also provide a Swarm FS node, and with this Swarm FS node, we are able to provide an NFS mount point, and with this NFS mount point, we can read and write data to Swarm. But that's more for legacy applications that does not support S3. It's not a replacement for an NFS file server, so it's not for random reads and random writes.
Okay, thank you.
You're welcome. No more questions so far?
Szanowni Państwo, zapraszamy do pytań, bo jest okazja też rozszerzyć temat i ewentualnie zapytać kolegę o jakieś tematy pokrewne, Państwa interesujące. Także zapraszam serdecznie. No questions at that time, I think, so we can continue.
Okay, great. Okay, then I was talking about that Swarm Telemetry VM, and what we see here, that's the Grafana component that runs on that Telemetry VM, and here we can see all informations regarding monitoring of the environment. Here we see the health report of everything. Then there is more informations where we can really get all details what's up with the system. So we can take a look on the individual nodes. So we can select the nodes here, and we see what's happening on that node. That's a really nice graphical overview. And we can get all informations. We can have a look about network bottlenecks and so on. Okay, then another advantage that Swarm brings is that we are really flexible when the environment grows. So when we need to scale out or when we need to replace the hardware, for example. I would like to show you how easy it is to scale out that storage cluster. And therefore, we will create another VM here. New virtual machine. Swarm node 6. We'll give it a storage device. That will be Linux. And let's give him 64 gigs. And important is that this new machine, where's the network? That one needs to be connected to the storage network. As I mentioned earlier, the VMs are booting over PXE, over the network, and that's the network where the machine boots from, so that's important. So we just create it and power it on. And we will see it's booting a storage node. So this will take about 90 seconds in real life. And then this storage node will join the cluster. Its disk will be automatically joined to the cluster, and the data will be rebalanced over all nodes. So we will need to wait some time. In the meantime, we could answer additional questions if we have.
Yes, hello. I have a question about this hardware dependency, or whatever you call it. You are adding another storage node. So, but basically, in the real life, all the storage nodes are on the same storage array. So why adding new nodes? Why not just increase the size of the node?
Sure, there are different scenarios. You could, if you have physical nodes, you could just plug in additional drives if you have free slots. That would be the easiest way to expand capacity. My demo lab is not really representative of that scale out.
Yeah, of course.
But if you would scale out in production, and you need more bandwidth, for example, because your existing nodes are saturated with its bandwidth, with its possible bandwidth. So you could add another node, and with that node you will get additional bandwidth, and it will all the requests that come into that cluster will be balanced over all that node. So that means with an expansion of a node, you will get additional bandwidth and additional capacity within that cluster.
Yeah. Okay. So another question. You said that the minimum number of storage node is 3 for redundancy.
Yes.
Why it needs to be 3? Because I'm assuming that, for example, we have virtual machines that are already on some array. There we have write settings and everything, so it's pretty much secured. So why we need 3, not 2?
It's because if you write the data into that cluster, you will always need a minimum of 2 nodes where you can write the data. If you don't have 2 nodes at minimum, you can't write. That means if you have 2 nodes only and 1 node fails, then you are not able to write.
Right at all. Okay,
That's
I
the reason
understand.
for the 3 nodes.
I understand.
Okay. Anything else? Any other questions?
One question close to this last question from Mr. Tomasz. So if we upload a file of 1 terabytes, how much capacity, physical capacity, will be consumed for this 1 terabyte file? I mean, how many copies of data we have in Caringo? 2 copies, more copies? How it looks?
That's different. That depends on the size of the object. You also specify the size, but if you have objects smaller than 1 megabyte, the objects are replicated within the system, and the default is 2 replicas. If an object that is written is bigger than 1 megabyte, the data is written with erasure coding scheme. And erasure coding can be configured what erasure coding you want to do. So I'm not sure if everybody is aware of erasure coding. Erasure coding is can be compared to RAID. But on RAID, we have all the segments on one machine distributed over different disks. With erasure coding, we can do the same, but we distribute the segments over different nodes. And we are also much more flexible because we do it in a software layer. So we are flexible regarding segment size and so on. And also when doing recoveries, all the nodes participate in that recovery, and that makes it much more faster than a traditional RAID. There was a test recovering a 14 terabyte drive in a Swarm cluster, and that took only 90 minutes. With a traditional RAID system, it would be, I think, minimum 2 days.
Yep. Makes sense. Thank you very much.
You're welcome.
Okay, so one more question for me. So theoretical situation that client wants to have 5 terabytes of storage, for example.
Yes.
So what he needs? 3 nodes, 5 terabytes each.
Yeah, with that smaller with that 3 node system, I would go for replication only. So that would mean you need you would need 3 times that capacity, because you want to have 2 copies, and in the case 1 node fails, you want to do a recovery for everything to the remaining node. So in that scenario, yes, you need 3 times the capacity. If you would work with 4 nodes, for example, you could configure erasure coding 4 to 2, which means 4 data chunks, 2 parity chunks. And then it depends how many objects are greater than 1 megabyte, but then you need not 3 times the capacity. 2 has an overhead of 1.5, I think, if I'm not wrong. That means you need in the end 1.5 times the capacity.
Okay. And one more question regarding the real-life sizing. Is it even is there a sense to use classic array for the, for example, client has already virtualization, they have some space left, but they have only one big storage array. So is it a sense to use 3 times virtual machine for storage node, and all of them will be hosted on the same physical drives, on the same physical array?
No, that's not, that makes not really a sense. Usually
I'm asking if you are using virtualized environment for each node.
Yeah.
There should be each physical device. Yes.
Yeah, each storage node, no matter if it's virtual or physical, should have independent disks.
Mm-hmm.
Usually we work with nearline SAS drives. We don't need and we don't use RAID controllers. So we need just a pass-through SAS controller. And then we work with that, I say, cheapest drives that are available. So you don't need any storage array, just plug in local drives to your ESX hosts, configure that for the virtual machine, for the storage node, and you are done.
So each drive will have a separate virtual machine, you mean, for storage node? Yes.
Yes.
Yeah. Okay. And what are the hardware requirements for the storage node? How many CPUs, RAM?
The storage node are that depends a little bit from the number of objects we have.
I'm talking about the small environment, few terabytes.
I think for a small environment we can we could start with around 4 to 8 cores per storage node and about 60 gigabyte of RAM.
60 gigabyte. Okay, thank you.
You're welcome. Okay, so our storage node is up and running. So then we can have a look on the UI. So we will check the hardware, and we see before we had 5, 1, 2, 3, 4, 5. That was the last node, and that is the new VM I created. We can also see that on the IP address here, so the 3.5 in the end. We see that also here. So that's our newly added node. It automatically joined the cluster, and we also see data is rebalancing. So the storage capacity on that disk will grow, or on that node will grow, and all the others will be a little less. So there was really nothing to configure to add this node to the cluster. We just created a new VM, installed a new physical server, connected to that boot network. It boots up, joins the cluster, and its capacity is usable. If we would do hardware replacement, and we want to replace that old node here, for example, we can go here and retire that node, which means all the data will be moved away. And if that node is empty, we can power it off and remove the hardware and throw it away, for example. So it's really easy to refresh the hardware. There is not really big migration tasks. It's just that adding new nodes and retiring old nodes. So it's really easy. Okay, that's all I wanted to show. If there is any question or anything you want to see, feel free. We can have a look.
Okay, one more question for more about the licensing. How is it
Yeah.
licensed?
Licensing is regarding the terabytes you use, which means licensing is all the files you write into that cluster need a single instance of license. So if you write 4 terabyte, for example, you need 4 terabyte license, and it doesn't matter if these 4 terabytes are replicated 3 times or if it's erasure coded. That's outside of the license. You just need to license the data you ingest into the.
So we are licensing front end, not the back end. Yes.
Right. Yes.
Okay. Thanks.
One question regarding use cases or scenarios we can imagine. In case of customer has also some cloud resources using some clouds, can we also connect Swarm to Cloud, replicate in one or other direction? Is it really something which makes sense? I think about the situation when the customer would like to first migrate part of the data to Swarm from the cloud, and maybe also other way. Could you please comment the most common use cases in such environment? Swarm?
So what we can do is connect to a cloud S3 bucket and use that as disaster recovery copy. So we can have another copy of all the objects on the cloud in the case that a whole cluster fails in a disaster. And then we can rebuild that cluster and regenerate all that objects from the cloud bucket. So that's for disaster recovery. To take over data from the cloud, there is no integrated solution. So there is an external component needed to transfer objects that exist on the cloud to a Swarm cluster. If you are doing that always depends on the application you are using. So if you're using the S3 bucket as target for VM as example, you could move that through the application, or most other applications can move their objects. If it's just users that upload individual files or objects, then there is a tool needed for that migration.
Okay, thank you.
You're welcome.
Any questions? Jakieś pytania, drodzy Państwo?
No akurat takie moje zasadnicze pytanie, to co od początku, wiesz co, brakuje mi takiej wiedzy, po co ten cloud storage, nie cloud, tylko object storage, czyli nie tyle, wiesz, jak działa, tylko dlaczego warto.
Słusznie. Stefan, it is very good questions, more from sales area, but maybe you have already good examples of experience from your side. The question is why we should think about using Swarm. What would be the real reason? What are the main benefits of using Swarm instead of other solutions?
For clients that do not use object storage at all right now.
Yeah, the big advantages you have is that it's really cheap hardware. You need standard x86 hardware. You need only nearline disks, and with that environment, you can securely save the data for ages, for a long time, for 10 years or longer. And with most other storage systems, you cannot achieve this. Within Swarm, each object has an integrity seal, and this integrity seal is continuously checked. And in the case something happens, if a bit flips or whatever, it's automatically repaired in the system. And it's not the case as on other systems that you first notice that there is a corruption when you read that object, because then it's too late. And that's the reason for Swarm. And that's the main use case for archiving or saving content really for a long time.
And
You're
what is
also really flexible regarding the hardware. You are not tied to or fixed to any hardware vendor. If in whatever time, 5 years, you won't use your Dell servers anymore, you can take whatever you want.
Okay, and for the customers who are using already some object storages, what would be the reasons, the main reasons to move to Swarm? Or second part of the question, can customer live and use both Swarm and existing object storages together, and if there are any additional value for such customer?
The advantage is that you are really flexible. You can scale as you need, and you have no. If it comes to performance, there is no single component that limits the performance or capacity or number of objects. All the components of that Swarm cluster can be scaled up as you need, and that's with many other object storages. That's an issue. If there is an existing object storage, you could use this also for disaster recovery, for example. If that provides an S3 bucket, you can use that S3 bucket as disaster recovery copy. In the event that the cluster fails, you can recover from that.
Okay, so the main argument would be simplicity of managing the such storage, security, additional level of security or high level of security, and lower costs.
Lower cost and the flexibility.
And flexibility, yeah. Okay, thank you. Any other questions? Jakieś pytania, drodzy Państwo, jeszcze się pojawiły w międzyczasie? Zerknę na czat, czy coś jest. Na czacie dużo było dyskusji. Nie widzę na czacie żadnych więcej pytań. Okay, so Stefan, it seems that there is no more questions from the audience, also from my side. So thank you very much for the presentation. Very clear demonstration of the products and all the discussion and answering our questions. So thank you very much for that.
You're welcome. And if there is any question also later, please let me know. I'm here to help.
Sure. We will let you know. The presentation will be or is being recorded, so we will present the link to the presentation if someone from your colleagues would like to get access. Zatem jeszcze raz powiem, prezentacja jest nagrywana, także będzie dostępna na naszej stronie YouTube'owej w sekcji tam zasobów. Po prezentacji w ciągu paru dni podeślemy linka, także w razie czego można będzie się podzielić ze współpracownikami, gdyby ktoś chciał jeszcze tutaj ten content obejrzeć. A z naszej strony na dzień dzisiejszy serdecznie dziękuję za uwagę. Zapraszam do kontaktu i życzę miłej dalszej części dnia. Dziękuję serdecznie. Thank you very much.
Thank you and have a nice day.
Thank you very much, Stefan. Thank you. Bye bye.
Bye bye.